At the end of the last video, I realized that there were a number of issues that I had that I needed to address before I could get to the next test. So I made a list so I could keep it all straight. The fetch register is incorrectly outputting the signals. There's a delay in there that shouldn't be. Fetch register and the instruction register need to be attached to each other, and I need to replace the ribbon cable with some hardwired connections. I need to attach the clock to the fetch register and hardwire that clock in. I need to complete power and ground on the memory and clock modules. There's only one. There needs to be two. I have a control jump breadboard. I need to attach that to the control logic breadboard and make sure that I add power and ground to that. On the jump breadboard, I need to create a landing point for the fetch register controls. I need to update the control EEPROM. I never updated it with any of the controls that I just put in place. I need to extend the control logic for the fetch register. I need to create a landing point for the R1 register controls on the jump breadboard. I need to update the landing point for the program counter register controls on the jump breadboard. I want to square the memory module to the PC register because it's not straight. There's 12 bits of the instruction register I need to extend to the control logic. I need to label all the LED controls so I can keep them all straight once and for all. And then there's a TTL to CMOS problem that I need to take a look at as well. All of this so I can properly test the NOP instruction again, correctly this time. I need to build out the logic for the move immediate instruction and do a test for that. Well, there's no reason crying about a hard day's work. Let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, these wires here are all connected to the wrong side of the line driver, so I need to relocate those so that they are on the correct side. The whole point of this is to make sure that I get the timing correct on the outputs from the fetch register to all the different buses. While I'm doing all of this work, you're going to get a lot of voiceover from me, simply because it's going to be a long video otherwise, so I want to make sure that I get as much work done as I possibly can. I've got a number of wires I salvaged off of an old project that I am using to cut up and make these connections so that I'm not using all new wire for this. So I've got these wires that are just stuffed in a bag, basically. And so I'm trying to straighten them out a little bit, use them. The next step here is going to be to connect these two breadboards together and then update the wiring between them. I get to remove the ribbon cables and I will replace those with some hard wires between here and here. So in case you didn't realize, the solid core wire that I use here as part of the hookups is different from the stranded core that I use in the ribbon cables and the temporary hookup wires that jump between the boards. And the reason is that the stranded wire actually can survive the movement better than the solid core wire can. The solid core wire will fatigue and break if it moves around too much. And since I have to move this build from one place to another as I'm doing stuff at my desk, I actually work my day at my desk as well. So as I move this around, I don't want these connections to fatigue and break on me. They can be a little difficult to track down if that happens. So now that I've got the two breadboards here stable relative to each other, I can use a hardwired connection between them now. Connecting the clock module to the fetch register and the instruction register is going to allow me to extend the clock all the way up to both registers using a solid core wire versus the stranded core, which I've had before. This is going to help clean up the build a little bit, make it look a little bit better. I refer to the breadboard in the bottom right-hand corner as a jump breadboard, but really what it's taking the place of in my PCB build is the backplane. It is the distribution point for all of the control signals. The only thing that's really missing from that board, which would be on the back plane itself, is power and ground. Okay, I'm going to leave this third connection tied low for now because I have to extend that up into the control signals. Okay, some of these signals I should already have sitting around, so I need to make sure that I extend those properly. Now I'm not sure if I've got those connected in the right order, so I will have to make sure that I double check those before I get too far into my testing. What I'm doing here is testing to make sure I've got these hooked up the correct way around. Okay, this one is for the R1 register. That's the landing point for that one. Now I'm going to use some solid core wire just to try to make this connection just a little bit more rigid. And hopefully I don't fatigue that wire too much. Okay, here I'm going to reuse some of the ribbon cables I had pulled off in the beginning. And this will be to hook up the low 8 bits into these EEPROMs. I've got several other addresses that I need to, or address lines for these EEPROMs I need to deal with. And for now, I'm just going to tie them low. There are also some control signals up here built into all of this that also need to be pulled low as well. Okay, that should be all my connections. This is one of those little fussy bits of work that makes all the difference in the world. I learned this lesson with my previous build and then promptly forgot it when I got to this build. Guess it's time to learn that lesson again. Okay, I think with all that done, I've gotten to a point now where some explanation is actually needed. The next step here is to hook the control signals here, specifically that of the instruction register assert. I'll have this zoomed in for you. I need to be able to bring this low, but I need to be able to do it based on logic. Now there's 4 buses that the fetch register can assert to. 3 of those are shared buses, so it's not like I can use 2 bits in the control logic in order to determine what's going to go where. And theoretically, we should be able to allow the fetch register to assert onto multiple buses at the same time. So that said, the control to assert to the instruction register is really only a single bit. It's either low when we want to assert or brought high to block the assertion. And so that's the one that I need to suss out and wire up. So looking at this, I have 3 bits here that have been used on my control ROM1, and ultimately control ROM1 is handling asserts so far. This would be the appropriate place to put that particular assert signal. And it's really not an assert signal, it's really the blocking of the assert. So ultimately what it is it is a instruction register suppress for the fetch unit or for the fetch register. I will work on going ahead and pulling that together. But in the meantime, on my circuit, this is going to be, that's bit 7, bit 6, bit 5. This is going to be bit 4 here. And that's actually going to be brought down to my instruction assert, and that line then goes away. That's the hardware that's going to go with the update of those control signals. So that said, let me get that wired up. So you might wonder why I'm not concerned with the timing of this particular signal. The fetch register and the instruction register work off the base clock, and that assert suppress signal needs to be as early as possible in the instruction cycle. So I'm not going to try to delay or decay that in any way. All right, that takes care of that. I did notice that I did not set the bit here for the main bus group 1, so I've got that cleaned up. And I copied out for bit 4 and made an instruction assert and an instruction suppress. And then down here related to the no-op instruction, I put in an instruction assert. It really doesn't matter if I do an assert or a suppress. The pull down resistors should fix that for me, but just in case, I'm going to go ahead and assert, and then I'll circle back to this if I need to. Okay, I had to restart my computer to get a few things. Okay, I had to restart my computer in order to get a few things working properly, but I was able to get these EEPROMs programmed. All right, so that said, I should be able to plug this in and see this run the NOP test. And it is not. So now I've got some debugging to do. All right, so that's being asserted properly. All right, I've got some control signals that are not right. So I'm getting the increment, but increment is not happening. I'm getting the assert out onto address bus 1. Getting the latch here. Getting the instruction assert here.
Getting the increment, but no increments are happening. Yeah, there was a lot of change. I'm looking down here at the reset, and the reset's working properly. I'm not getting an end latch here. Alright, so it looks like control ROM 3 did not actually set those bits. So I need to set those bits there. So this isn't a hardware problem, but rather a firmware problem. Let me get this reprogrammed. Okay, let's drop that in again and see what happens with that. Okay, so here is my logic probe. All right, so let's see here. Do I have a clock here? I do not have a clock here. And I should have a clock here, which means I don't have a clock here. That looks like it might be floating. Okay, so there's my automated clock. I've lost something there. Did I lose this IC here? That's always low. That's flashing between high and maybe my 556 went bad. I am not picking up low coming out of that 556. So that's high, that's correct. That's high, that's low. Low. Okay, so this one's at least showing low. That one's not showing low. Yeah, something's in the wiring then. Alright, let's start by disconnecting my clock. Now that appears to be working again. Yeah, that's actually properly outputting a high and a low signal. That's counting properly here. When I hook that up, it shuts it all down. Let's take this out. Means I've got this in the wrong spot up here. That should be there, and this should be over one there. All right, let's put this back. Okay, where are we at here? I'm counting here. Am I asserting here? Or asserting to here, I should say. Oh, this is working. So my address here is all pulled low. And then that means that my instruction that's being passed over here is a no-op instruction, which should be causing this to increment, which it is. So I'm troubleshooting a non-issue. That's fine. I figured I'd show this to you. I was soldering up my new bus connection for the main bus, and as I was testing it to make sure I didn't have any cross connections, you can see I do. And I've actually marked the two that are cross connected here with some black dots so I can keep track of them. So I've got two traces that are bridged. Let me get this under the microscope here, and we'll see if we can identify where that is. And it's pretty easy to spot. Grab a pointing implement. It's pretty easy to spot right there. So I don't know if I can take the soldering iron and clean that up, or if I'm going to need to actually do some solder wicking. Let's see if I can try the soldering iron first and see if I can just separate those two. That may or may not have worked. I'm not certain. And so it looks like I've managed to separate those two. I'm going to do a little bit of digging here just to make sure I don't end up with something that I'm fighting in the future. So that's at least good. As I'm dropping components on my puppy sitting at my feet. Okay, so now I've got separate electrical connections. That's good. Now to get ready for the last test in this video, I had to modify the architecture file so that I had a move instruction into the R1 register of an immediate 16-bit value. And I've done quite a bit of changes to the actual assembler itself in order to support that. You can see this by all the modified tags. I'm going to have a copy of this source code pushed to GitHub by the time I publish this video, so you'll be able to go and take a look at all those changes yourself. Having done that, I had to put together a test which used those instructions, and basically I have an LED that's sliding back and forth from least significant bit to the most significant bit, and then turn around and go back down to the least significant bit. Many will recognize this as a Larson Scanner or the Knight Rider effect. It should be relatively easy to identify if things are working properly or not. And finally, I had to update the control logic, and what I did is I went out here and created some aggregates, if you will, of some instructions, some things that I'm going to do more frequently, such as asserting the fetch register onto the main bus and then load and latch on register 1. So this takes care of a couple of the control bits that need to be set for each one of those, making the coding a little bit easier. I added my move R1 an immediate value instruction, and then of course some comments were added in as well. This helps to identify exactly which bits I'm programming here in the control logic, which is different than what the assembler is outputting. And then some updates here. Specifically, I needed to make sure that I handled the new instruction in the control ROM. Okay, I programmed the EEPROMs off camera, and so I'm going to drop these in. And now I realize that I'm getting very close to my ideal video length. So if this doesn't work, I will end the video here and unfortunately leave a little bit of a cliffhanger. If it does work, then that's fantastic. This is the main bus that I soldered up, and you saw some troubleshooting on the back of that. And I'm going to drop this and kind of wiggle it right in here. And I did this so I can drop my main bus connections up here. This is the main bus for the fetch register. That's the main bus connection for the fetch register, I should say. And then this is my previous PCB, which will not work for increments and decrements because the signals associated with that are not wired up properly, but it will work for loading. And I'm having a heck of a time getting this ribbon cable seated. And then I'm going to go ahead and drag, I soldered this onto the PCB here just for being able to get power because I don't have a power connection otherwise. And the last connection here is the control signals. Now again, this is upside down. Next, I have to actually hook up the main bus assert associated with the register 1. And so that is going to be, no, I'm sorry, the main bus assert associated with the fetch register. And if you remember, the main bus assert is associated with these demultiplexers. And what I have here is I've got the different signals and where they're going to fall on the demultiplexers. And so the fetch register is on the second group, and it's the 4th pin in. So that would be hex 1-3. And so I just need to find the right location. So this would be 1-0, 1-1, 1-2, and then 1-3 is right there, which I'm going to drag over to this location, replacing where I had it pulled high. So now this signal is driven off of the demultiplexer at that point. And so the first thing I want to do is I want to apply power. Now over here I still have just a 0 address working. And so now if this works, what's going to end up happening is that I'm going to end up loading into this register here the value of the instruction itself, and so I should be able to see that load. Now I want to make sure that I have this on manual before I power this up so that I can step my way through this. And I am going to have to I have to come up with some method of clearing that program counter. So let me drop a signal wire in here, pull it high to clear it, pull it back low. Do I have that in the right spot? Let's drop it up here. Well, apparently my clear isn't working either. It may be just disconnected. Let's try that again. Clear, and then I have to and latch. Okay, so there is address 0. And I am not fetching anything. So it's all still no ops. And there's a really good reason for that. I did not update these EEPROMs. So let me do that. Try that again. And then we take that high to clear it. Step once. And I'm still not. Ah, I am. This is working. I'm fetching 1.3, which is the instruction. But what I'm not getting is I'm not getting these actually driving the control signals. And I actually expected this. And that's because I've got HC logic here, but LS logic here. So the problem is that the LS logic high is not high enough to meet the threshold of the HC logic. So I believe that a pull-up resistor here, strategically placed on several of these signals, is likely to be able to help these come high. So now I've made a mess of this. Okay, so let's try a reset. Clock once, back to a 0. I've loaded the instruction. And the problem is it is not, while I have LEDs on here, it is not actually latching the value that's here. And I am expecting, no, I'm not expecting that to, yes, I am expecting this to assert to the main bus, and it is not asserting to main. All right, well, as promised, I'm going to end this video here. I'm going to follow up with a troubleshooting video, and we'll see what we can do to get this working properly. I am still incrementing, but there's something not quite right yet with the assert here. Let me just try one quick thing, see if I got this backwards. How about this one? No. All right. Yep, I'm going to end this here. That said, I apologize for the audio. I think I've got it dialed in now that I'm coming up to the end of the video. Thanks for bearing with me as I get through this. I do appreciate your time, and I hope I haven't wasted it. Thank you, and we'll see you soon.